So this is lesson 5, the reference angles and evaluating the homework. So for the first couple, it says for each of the following angles, first we're going to draw a rotation diagram. So for 185 degrees, we need to figure out which quadrant it would fall in. So if you remember, 0 degree starts on the left, and then we go counterclockwise, 90, 180, 270, and then back up to 360. So 185 is between 180 and 270. So we should be drawing our ray in the third quadrant. And rotation, remember, we go counterclockwise. So there is the 185. B, identify the quadrant. Well, we had to do that in order to answer the question and draw the diagram. It's in quadrant 3. So part C, find the reference angle. So you remember your formulas in the lesson. We have theta, 180 minus theta, theta minus 180, and then 360 minus theta. So third quadrant, we're taking theta, the 185, and subtracting 180 to get 5. For B, same thing. In order to figure out which quadrant we're falling in, we do have to convert 11 pi over 6 into degrees. So we're going to multiply by 180 over pi. So 11 over 6 times 180 is 330. 330 is in the fourth quadrant because it is between 270 and 360. And again, we rotate counterclockwise. So this is that 11 pi over 6, or 330. So part B, this was quadrant 4 that we fell in. So C, our formula says 360 minus theta. So 360 minus 330 equals 30. Now, technically, the directions do say to find the reference angle in the given unit. We were given a radians unit, so technically we should be converting back again by multiplying by pi over 180, or 1 pi over 180. So 30 times 1 over 180, you get 1 over 6 pi. For C, rotation diagram 120 is in the second quadrant because it's between 90 and 180. Again, counterclockwise. So we just said second quadrant. So the formula for the second quadrant, 180 minus theta, 180 minus 120. You should get 60 degrees. Okay, question 2, evaluating this. We're going to have to convert each of these angles into degrees in order to evaluate. So I'm going to do it over here on the side. So the first angle was pi. We're going to multiply by 180 over pi. This first pi is technically over 1. So the pi's cancel. And you're left with 180 degrees. So this first one we're doing here is cosine of 180 degrees. Next, we had a 3 pi over 2. We're going to multiply by 180 over pi again. The pi's cancel, and then 3 over 2 times 180 is 270. So here now we have sine of 270. Next angle we have pi over 3. So same thing, multiply by 180 over pi. These pi's cancel. This is technically 1/3 times 180. So you should get 60. So we're finding secant of 60. Now, to get the cosine of 180 and sine of 270, that was the beginning of lesson 5. If you remember your unit circle, here's our 0, 90, 180, 270, and then back up to 360. Each of these intersects the x and y axis at specific points. Over at 0, 360 was the point 1, 0. Up at 90 was 0, 1. Then we had -1, 0. And then 0, -1. Cosine 180, cosine is the x. So over at the 180, the x is -1. Sine 270, sine is the y. So down at 270, the y is -1. Plus, secant, remember, is the reciprocal of cosine. So we need to find cosine of 60 degrees. You're going to use your chart for that. So cosine of 60, you should see is 1/2. So taking the reciprocal, we get 2 over 1, or just 2. -1 times -1 is 1. Plus 2, you should get 3 as your final answer. Question 3. On the unit circle shown in the diagram below, sketch an angle in standard position whose degree measure is 240, and then find the exact value of sine of 240. So you remember 0, 90, 180, 270, 360, 240 would fall in the third quadrant. It's between 180 and 270. And we rotate counterclockwise. So there's my angle of 240. Now, to find sine of 240, these were those steps that we had at the end of lesson 5. Which quadrant are we in? We are in the third quadrant. So what is the sine of our function? Well, our function is the sine function. Third quadrant, we said we're going to use ASTC to find this out. So third quadrant has a T for tangent. Only tangent is positive there, which means our function sine has to be negative. And then our reference angle, we're going to use the formulas. Third quadrant says theta minus 180, so 240 minus 180. And this tells me to find sine of 240, we're going to do negative sine of 60. Sine 60 is on your chart, so you're going to go to your chart to pull it out. You get radical 3 over 2. And we said it's going to be negative, so our final answer should be negative radical 3 over 2. Question 4. An angle with measure 7 pi over 4 radians is in standard position. What is the reference angle? So I'm going to start by converting this into degrees. So multiply by 180 over pi. So the pi's cancel. And you should get 315. So what is the reference angle? Well, 315 would fall in the fourth quadrant. So the formula in the fourth quadrant, 360 minus 315, you get 45. Part B, what is the exact value of tangent of 7 pi over 4? So that's really tangent of 315. So same thing I did on the last question. Q quadrant. We already said it's the fourth quadrant. SF, sine of our function. We are dealing with the tangent function. We use ASTC to find this out. So fourth quadrant, C, cosine. Only cosine is positive, so tangent is negative. Our reference angle, well, we did that up in part A. We got 45. So tangent 315 is the same thing as negative tangent of 45. So from your chart, tangent 45 is 1, and we're going to throw the negative on it, so negative 1. Question 5, find the exact value of cosine of 3 pi over 4. So again, we have to convert our angle, multiply by 180 over pi, and you should get 135. So we're looking for cosine of 135. So Q quadrant, 135 is in the second quadrant. It is between 90 and 180. SF, sine of our function. This is the cosine function. So ASTC, second quadrant is S. Sine is positive, so cosine is negative. Our reference angle, 180 minus theta, which is 135. So we get negative cosine 45. So from the chart, cosine 45 is radical 2 over 2, and it's negative. Number 6, which expression is not equivalent to sine of 150? So sine of 150, we can do the Q, that's the second quadrant, SF, ASTC, second quadrant is S. Our function is also sine, so this is positive. Our reference angle, 180 minus 150. So we have positive sine of 30, which from the chart is 1/2. So this one up here is 1/2. So we want to know which of the following is not going to be equal to 1/2. Well, A would be, because sine 30 is 1/2. So it's not that one. C, cosine 60 from the chart is also 1/2. So it's not that one. And D, we have negative cosine 60, so negative 1/2. Well, that is not the same thing as positive 1/2, so it is answer choice D. If you want B, it does come out to 1/2. You could do that QSFR with B also. Last question. Justify why this fraction is equivalent to x to the negative 1/12, y to the 2/3, using properties of rational exponents. Rational, remember, means fractional. So with radicals, that means we are doing power over root. So up on top, x has a power of 2. The root is 3. The y has a power of 5. The root is 3. In the denominator, x has a power of 3 with a root of 4. And y has a power of 4 with a root of 4. Dividing means that we are now going to subtract the exponents. So for the x's, you are doing 2/3 minus 3/4. I would plug that into my calculator if I were you. Otherwise, you need to find common denominators. You should get negative 1/12. And then the y's, same thing, 5/3 minus 4 over 4, or 1. You should get y to the 2/3. So final answer, you just showed all the steps as to how we got from that original fraction